All right, guys, second piece to this absolute value puzzle that we're gonna look at here is graphing each one of these. So I've got two examples here, and the directions say to graph each function, compare each graph to the graph of f of x equals the absolute value of x, and then we want to describe the domain and the range. All right, so let's go back here and talk about comparing each graph to the graph of f of x equals the absolute value of x. Notice that I put a light purple box around here. This is referred to as our parent function. And basically all absolute value graphs are going to stem from that. So when we're graphing, we're going to reference that. And what I need you to remember here are these 3 points. -1, 1, 0, 0, and 1, 1. These 3 points make up our parent function. So we're always going to start with these 3. -1, 1, 0, 0, and 1, 1. Second part of this is describe the domain and range. Remember back to section 3.3 or chapter 3 when we were talking about domain and range. Domain is another name of asking us, another way, of asking us to identify our x values, and the range is another way of asking us to identify our y values. All right, so let's start by graphing. So I want to graph g of x equals the absolute value of x plus 2. So the first thing that I did was I graphed my parent function, because not only do they want me to graph this, but they want me to compare it to this. So I started by graphing these 3 key points. All right, so you can see here I've gone out -1 and up 1, 0, 0, and 1, 1. All right, so now what I'm going to do is I'm going to look at my function that I've been given. What I have is a plus 2. This outside plus 2, that is our k value. And remember with k, what you see is what you get. So here I have this plus 2. So this right here is what I see is what I get. So this is telling me to take this function, these 3 points that I currently have graphed, take these 3 points and move them up 2 units. So I'm going to start here and I'm going to go 1, 2. I'm just going to take that point and I'm going to shift it up 2 units. Now I'm going to go to this point and I'm going to shift it up 1, 2 units. And now I'm going to go to the third point of my parent function and I'm going to shift it up 1, 2 units, because that plus 2 indicates a vertical translation of 2 units up. And so we took all 3 of those points and we moved them up 2 units, and we have successfully graphed g of x. So how does g of x compare? It is a vertical translation of 2 units up. Next thing we need to do is describe our domain and our range. So we need to describe our x values. So if you want the x values, that means we need to look at the x-axis. So if you look at the x-axis, I have points all along here. So my domain for this is going to be all real numbers. But my range is different. My range is my y values. And if you look at the y values, that means you want to look at the y-axis. We don't have any y values down here. There are no y values down here, okay? Our smallest y value for this function is actually right here. It happens at +2. This is our smallest y value. And then we have y values that are greater than that. So here, our range is y values that are greater than or equal to +2. All right, so now let's take a look at what we have over here. So here, They want us to graph m of x equals the absolute value of x plus 3. And notice that that plus 3 is on the inside. And then we need to compare that to our parent function. So I always start by graphing the 3 core points of my parent function. Negative 1, 1, 0, 0, and positive 1, 1. I'm going to start by graphing those 3. Then I'm going to go back to my function and I'm going to look at what I have. I have a plus 3 on the inside. So if I go back up here to my notes, our rule for what happens inside the absolute value here is do the opposite of what you see. So if I come back down here, I see a positive 3. So I'm going to do the opposite of that. The opposite of that would be a negative 3. And if something is negative when we are graphing it, that means we are going to the left. Okay? Negative in terms of graphing is to the left. Positive in terms of graphing is to the right. So again, going back here to what we have, do the opposite of what you see. So I see a positive 3. So the opposite of that is negative 3. So I'm going to take each one of these points and I am going to shift it 1, 2, 3 units to the left. 1, 2, 3 units to the left. 1, 2, 3 units to the left. And then I'll go ahead and connect those. Sorry, not the greatest. And that is what the function of m of x looks like. How does it compare? It is a horizontal translation of the parent function 3 units to the left. So that is how it compares. It is a horizontal translation of the parent function. So it's taking the parent function and shifting it 3 units to the left. And then what is our domain and our range? So again, domain is our x values. So if you want the x values, you need to be examining that x-axis. And so here, our domain, once again, is going to be all real numbers. So x equals all real numbers. Excuse me, I'm sorry. I obviously have what my kids have. And our range is the y values. So if you want to figure out what the y values are, you need to be looking at that y-axis. And so if we look at this, we don't have any y values below 0. There's no y values happening down here. So our smallest y value is right here when y equals 0. All of our other y values are above that or are greater than that. So our range is going to be y is greater than or equal to 0. So that is how you graph each of these. That is how you compare them to the parent function, which is f of x equals the absolute value of x, or excuse me, f of x equals the absolute value of x, and then how you describe the domain and the range for each one of those.